Algorithms in Internet Explorer, various versions ranging from version 5, 6, 7, 8, 9 up to 10. Background of content sniffing is what we will first talk about, because before going into attack, we should know the background, why basically browsers need to sniff the content and how actually the contents are sniffed, and then what are the various algorithms and how you can actually bypass the security mechanisms in the content sniffing algorithms, and then possible attack vectors which would lead to executing scripts and much more. We'll see about it. So first of all, we'll talk about why browsers sniff the contents. As you can see on the slide, first of all, the main concern here is there is a basic flaw in many web servers. Web servers generally tend to send an improper MIME type. Generally, whenever a server sends a file to a browser, basically an uploaded file which a browser needs to download and execute on its own, browser basically looks for a content type based on which the browser understands what type of file it is and what it is supposed to be doing with that file. For example, you can take example of Wikipedia. On Wikipedia, you can see a lot of images uploaded for various articles. These images, basically a browser needs to download and display it to you. Similar thing applies to many other applications, web applications such as various mail service providers. If you send an image, any photo of yours to any of your friends using email, that basically your friend will go to the email account, check the mail, and the mail provider, mail service will allow him to not only download that image but view that image using its browser directly without needing to download it. Now, basically, a browser basically needs to understand whatever file it has received from server, whether those are valid files or not, whether browser can execute the files on its own or not, and then how it can determine what type of file it is and what kind of stuff is to be done with that file. So basically, content sniffing is done with the files of which content type is not properly understood by the browser. Whenever you upload a file to any kind of web application, if the web application cannot understand what type of file is uploaded to the server, it will not send a proper content type to the browser, and then browser will not be able to understand what kind of file it is. So the browser will sniff the contents of the file and will try to determine what kind of file it is and then execute it. So this is why a browser needs to sniff the contents. What happens when a browser tries to sniff the contents of a file? First of all, they go on sniffing, that is, check the actual contents of the file, such as a file header. Basically, a file header will tell the browser what type of file it is and what it can do with that file. If the header is not valid, if there is some problem with the header, then the browser will go on sniffing the actual data of the file, actual contents of the file, which can be anything such as image data, HTML or script data, document related stuff, or anything, literally anything, whatever type of file can be uploaded, that type of data. If the browser understands what type of data it is, it will do that particular thing with the file. For example, if a browser recognizes that particular data to be image related data, it will try to display that as an image. If a browser renders that as a HTML data or script data, it will try to execute those scripts. If it does not understand anything, if it does not understand the file's contents, browser will simply give you a download prompt and will ask you to download the file. Now, the good part about content sniffing is, as we have already told, basically many times many web applications, web servers do not properly send the content type. Many times it can happen that even a valid file a browser cannot render properly, and thus a web application does not run properly on various web browsers. To overcome this, basically web servers whenever a browser receives any kind of file from a web server which it does not receive a proper content type from server itself, the browser will try to sniff the contents and will try to execute the file on its own. Considering this, basically, it does it to determine what type of file it is and what it should do with that file, so that a user will get maximum possible visibility for any kind of web application. Many times it happens if even if it is a valid file, a server will, if a server is misconfigured to send some malicious or some wrong content type, the browser will not be able to properly display the contents of the website. To overcome this problem, basically, content sniffing algorithms can be used, and that is the good part with the content sniffing algorithms. But the bad part with the content sniffing algorithms is a browser cannot understand whether the file it has received from the server is malicious or not, whether it is a good file or it is a bad file. Basically, many applications allow file uploading functionalities wherein a user can upload any kind of files, whatever files. If the web server or the web application is not validating those files properly, then a user can use that uploading function to upload malicious files and trick the browser to sniff the contents and recognize that file as a different type of file. For example, image uploading functionality can be abused, an improperly implemented image uploading functionality can be abused to upload script files, and a browser can be tricked into executing those scripts. So the web application basically will allow a malicious file to be uploaded on the server, and user considering the website as a trusted website will go and check the contents and will execute the malicious contents. So this is the bad part with the content sniffing algorithms. Basically, web browsers version 5 of I and later have implemented content sniffing algorithm. Firefox implemented content sniffing algorithms from version 2 and later. Safari version 3.1 and later use this content sniffing algorithm mechanisms. All these browsers have implemented this content sniffing technique as a functionality. The concept of content sniffing remains same for all the browsers, but the way they have implemented it in various browsers and various versions has changed. Basically, version 5, 6 and 7 of Internet Explorer use a different kind of algorithm. Browser version 8, 9 and 10 of Internet Explorer use a different kind of algorithm. But we have observed that all these versions can be tricked to execute malicious files. Algorithms used by I, 5, 6 and 7 basically prefer the content sniffing algorithm to the information received from the server. Whenever Internet Explorer 5, 6 or 7 receives the file from a web server and checks the content type sent by the web server, it will see what content type it is, what type of file it is, but it will never trust the web server. It will execute its content sniffing algorithm on that file and will try to determine itself what that file is and will execute the file on its own. But in Internet Explorer 8, 9 and 10 version, it basically prefers the information received from the server than to its CSA algorithm. Basically what 8, 9 and 10 do is, if they receive a proper content type header from a web server, they will execute the file, they will treat the file accordingly. They will never trigger their own content sniffing algorithm if a content type is properly received from the web server. So the trick here for all these versions is to confuse content sniffing algorithm such that it will read the malicious data included in the files and execute it. The tricks are different in both version 5, 6 and 7 and 8, 9 and 10. Anil here will explain you how the content sniffing algorithms work in all these versions, what kind of bypassing techniques can be used so that content sniffing algorithm can be tricked into executing malicious scripts, and he will also provide you with the demos.
Okay, so here let's start with I version 5, 6 and 7. In the browser, firstly, as Chaitany already discussed, that it will handle a content type sent by the server. Okay, servers basically work with the MIME types. Okay, each server like IIS and Apache are having its own definition which will describe that which kind of extension is which kind of content type or MIME type. Basically, it's Apache. Let's say an example of Apache. There is a file called MIME type in which it will describe a JPG is image/JPG, then PNG is image/PNG. And likewise, like if it's a MS Word, then it will be a MS Word / application. So browser will understand that okay, this is a document file, and it should execute this file with a document, basically like MS Word or any document handling application. So what we are doing here is basically the browser will get an invalid content type. Okay, let's say. It's an image/JPG, okay, and it will validate against extension received by with the URL, basically with the URL. Suppose if URL is xyz.jpg, okay, so now it's a JPG extension and content type is always it's JPG, so image/JPG will be sent by the server. So now here where the actually vulnerability relies in 567 algorithm is, even if server will send it content type as image/JPG and extension is JPG, still it will try to execute content sniffing algorithm on its own and will try to determine which kind of file it is. So the trigger will basically here will trigger the actual vulnerability if there is a conflict in matching the header value with content type and extension. As I said, suppose the server is sending content type as a image/JPG, extension is JPG, and the header, actual image header is containing PNG's header. Okay, so here this algorithm will get confused. It will not understand, okay, this is a PNG file, as header is suggesting it as a PNG, but content type sent by the server and the extension is suggesting it as a PNG. So it will get confused and it will go for a second chance. Basically in second chance, what this browser will do, they will sniff all the contents from start to end. Okay, the file is having contents. In that we will be adding a malicious JavaScript. Okay, so basically when it will start sniffing the content, it will find a JavaScript which will be a HTML tag basically, or Java, you can say Java function or Java, it's a tag. So basically when it finds a second number JavaScript at the second number, it will consider it as a HTML file and will try to handle its own. So it will execute that particular image file as an HTML and try to execute all the tags included in that file. So basically here how we, this particular that file will get executed and whatever script is included in that file, it will get executed. Okay, so this is the same thing which I explained right now. Okay, so just to elaborate with an images and some diagrammatically, this is how it is. First content type which are sent by the server. There is a image/JPG. There is a content type which is sent by the server. Then the extension it will collect from the URL itself, which will be a JPG. Then okay, this is the first chance. Okay, basically first chance is executing actually CSA algorithm, that is content sniffing algorithm. So when it will execute this algorithm, it will check for the file's header. Okay, so when it will check for the file's header, it will be a PNG. Okay, so this is where browser's algorithm will get confused. Okay, content type is image/JPG, extension is JPG, then why this header is PNG? This is where it get confused. So it will go for a second chance, and second chance will be, it will be sniffing complete file from start to end, and where it will find a script, JavaScript, and there it go. The script will get executed as an HTML. This is another one. This is a complete method how we created that malicious file. So first, take a valid PNG file. Okay, open it in any notepad or any of the like editor whichever you like. Then replace some unimportant data. Like sometimes there is unimportant data such as when this image is created, date, time. Then if author is there, then the author's some comment or licensing or blah 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 blah. So you can just, those are non-important data and which will not affect actually image viewing or image graphics. So you can just change that data, okay, and include your malicious script and replace that particular data with your malicious script. So your image will be valid, okay, graphics will be perfect, there will be no change in graphics or anything, and then just rename it to some other extension. Okay, as we are saying that this is a PNG file, okay, so header will be PNG itself, then we will rename it to JPG, okay, I'll show you the exact how we are gonna create this image. So let's create file. Okay, so this is a valid PNG file. Okay, if you will open it, it will open with the normal photo viewer or image viewer. Okay, so let's try and make it a malicious file. We will actually edit it with the Notepad++. Okay, so this is the image, okay, and all this is a content of the image. You can see this image, okay, and so this is actually the header of the PNG image, which indicates that this is a PNG image, and all the application will identify this image or even execute this image after it just check the header of the files. Okay, so this is the header. Then we'll just go ahead and check where the like non-important data is available in this file. So basically there was one section here that is text comment. Okay, this is the actually comment section where normally author put their comments about the image or anything. So we just replaced it, and we replaced it with the script that is the normal alert script which we use in XSS for fun. So this is where I use actually a script. Okay, then let's save it. Start a command prompt and just rename that file with JPG. So here it suggests that the its extension is PNG first, and we are renaming it to JPG basically. Enter, it got renamed. So this is a new file which we just generated. See, this file is same, content is same, it's showing the same thing. Okay, there is no difference. Even if we will check with the media info, even if we will see with the media info, it will show us that okay, format is PNG, format info, portable network graphics. It will show you the pixels and everything. So here it indicates that this is a valid image file. So now let's go and we'll try to upload it. Here we are using a Rediff mail for a demo where this actually we found this vulnerability, and there are multiple giant applications like even we found in Gmail and lot of other applications the same vulnerability. So let's start Rediff. Here it is Rediff. We'll log in. No. Of course, net connectivity. Finally. Okay, see, so here I'll write one message to myself. But basically I don't want to harm any other user. Ethical. Select a file. Is the file, so you can see it's showing type as a JPG image, okay, but the header is PNG. We'll just upload that image. It's scanning for the virus, but obviously it's a JavaScript, so it cannot be a virus or antivirus. Okay, just sending the file. Has been sent. Okay. Now we will open this particular same mail from our other VM, that is XP, and the browser is i7, because we are going to show you how this vulnerability executes the JavaScript in i7 basically. Okay.
Refresh.
Well, I guess it will take some time to come up mail. So let's say I have some other test mails, so I'll show you those mails in which the same files are sent. Okay. So there is a JPG file which we just sent. So when I click on this, okay. So this is my script got executed. Basically, again, as I said, XSS is not limited to just pop up message box or anything. We can use a lot of things with XSS itself. Okay, so this is the demo for i7 basically. Now we'll move with the other versions of i, and let's start. Okay, so this again, so yeah, I'll do one thing. I'll start VM first for Windows 8, which is using actually Internet Explorer 10, and this vulnerability relies in that version also. We already reported to Microsoft, but still they are working on it. I don't know why they are taking that much time. Yeah, they should. They should. You can't blame them. Okay, so let's start with the algorithm. Okay, first in this, what the thing is, again server will send content type. Then what they change in i8, 9, 10 is basically in 6 and 7 the algorithm was not actually like depending on the content type sent by the server, and it was trying to use its own algorithm to just find out which kind of file it is. So they just overcome this particular functionality to, like, don't know what was their thought, but then what they are doing right now, they are just going for the content type, okay, and the server is sending perfect content type like image slash JPG, then it will not execute the content sniffing algorithm and directly go for executing that image file, and it will show a perfect image without executing the JavaScript or anything, because it is not going to sniff the content of that particular file. Then if the content type sent by the server is MVGS, that is if it is application slash octet stream, okay, this particular content type suggests that this file should be executed using some other application, not by the Internet Explorer but some other application. So it will check for the extension, okay, so extension will be JPQ. So it will find JPQ. Here we are using JPQ to just social engineer the victims, as we know that normally extensions are JPG, and when we put it as a link, the line will just wrap the G into Q. Okay, so it's very hard to differentiate JPQ and JPG itself. So now we are sending a JPQ file. So it will try to check if this JPQ file is valid using its own test cases included inside the content sniffing algorithm. Okay, but again it will not find what kind of JPQ file is. So it will go with the registry entries in which there are extensions and the associated application. Right. So this extension should be executed using this particular application. But again JPQ is not there as it's a not regular extension. Then it will go for a third check, that is trigger the extension against the registry entries of its run. Then finally the content of the file. Okay, it will start sniffing the content. It was not able to get actual content type from the server. It was not able to get exact extension of the file and associated application. So now it will try to sniff the content and try to check which kind of file it is. So here what we are actually doing, we are configuring a server, or we can say that the server should be a misconfigured. Okay, these are dependency basically. Server should be a misconfigured and it should be sending unknown file type as application slash octet string. Basically, in lot of default configuration, server will send you unknown slash unknown, as it's not knowing which kind of this file type is. So it should send actually unknown slash unknown, but few misconfigured servers are sending application slash octet string. So this is what we are doing. We just uploaded one file, JPQ file. So now server has sent us application slash octet string. Then now it got confused. So it will try to check which application should be used to execute this particular file type, JPQ file type. So it will check with the registry and try to find out which application can be used to execute this particular file. So that's it. It will not find that particular application because JPQ is not associated with any application basically. So there we got what we wanted to do. We wanted to just execute that content sniffing algorithm, and we wanted to force the algorithm to try to sniff all the contents of the application of the file. So again, just to elaborate, content type application octet string, then extension, that will be a JPQ. It's similar to JPG, looks like that. So it will check extension where it will get fed. Then file header. Okay. So here the actual content sniffing is getting started. It will try to check which kind of header is there. The image header. So there will be a PNG header, and then after few bytes again there will be a normal JavaScript kind of, or any script, and there we go. It will find a JavaScript. It will consider it as an HTML file and it will execute those HTML tags. So let's see how we can create that file. The same procedure, the only step will be different here is we are going to rename this file. Instead of JPG, we will rename it as JPQ. And no difference. The file contents are same and everything is same. You can change your file content as per your need. Okay, yeah, right. Yeah, even that is true. The problem currently we are facing here is the internet is not working correctly. So we'll just show you the same demo which we were trying before this presentation outside. And okay, the same mail is here. Okay, here is the JPG file. Let's see how. See, you can't actually recognize which is JPG and which is JPG file because there is an underline as it's a link, so you are not able to find. Okay, so this is how we are going to track a user. See, there is a JPG file and there is a browser version 9. Actually, this is working on 10 as well for your information. Okay, 9. Let's try to execute this script. Okay, really. So 8, 9, 10 is vulnerable and still we are getting XSS script. We can do a lot of stuff. As I already mentioned that access is not limited for popping up a message box. Okay, so this was again like demo of Reddit mail, and as I said there are some dependencies like application should be having some upload function like a trusted application basically like Reddit mail as we shown Reddit mail demo. Reddit mail is very much trusted application and I guess many of users are having a Reddit mail account. They check their mails every day. Okay. In case of 8, 9, 10, a web server should be misconfigured. I already mentioned that that web server should be sending octet slash string, application slash octet string instead of unknown. And well, sending that header value is considered as functionality by most of web servers. So that depends. Okay, so real life example, as I said already, that Gmail was vulnerable and because of that I got few bounty rewards on Gmail, and yeah, that is a secret of my Google Hall of Fame. Okay, the next part will explain Chaitanya.
Thank you, Anil. I hope you guys are now quite aware of how we can execute XSS scripts using malicious files in any version of Internet Explorer from 5 to 10. Here is a scenario in which we have used this particular vulnerability, you can say, to get root access of a file of a server. Basically, the scenario here is a web application which is having a normal user for doing his kind of stuff, whatever stuff he is supposed to be doing, and an administrator user who is supposed to be moderating whatever normal user does. There are a lot of applications which allow this kind of functionality. A normal user who kind of like work on some information received or any kind of stuff, and an administrator is supposed to review whatever information the normal user is processing and uploading or giving out, whatever. We can take an example of an application which allows the normal user to create and upload, let's say, tender files, tender documents. A normal user is supposed to upload tender documents to a portal, and an administrator's job is to review the tenders that are received from a normal user and do whatever the next thing is. In this case, the normal user can upload tender files. We are talking not only about image files or anything. We can, obviously a tender will be most probably a document file. So any kind of file can be used in this kind of attack. So the normal user has functionality to upload these kind of files on the web server, and administrator's job is to view those files and review those files and then give the normal user any kind of response or whatever. But in this scenario, the normal user is not happy with his privileges. He wants to do something more. What he can do is, the attacker actually can host an Internet Explorer exploit using Metasploit. I am not sure whether how many of you know that you can use Metasploit to host Internet Explorer exploits. If you can you configure your Metasploit so that you host exploit on your own system, and Metasploit generates a link. If anybody visits that link, their browser will be exploited. Their browser will receive a file which will exploit their browser, and then if the browser is vulnerable, the exploit will work and you can get a interpreter session. So the attacker first hosts a I exploit using Metasploit and generates a link. Then the attacker can create a file having redirect script to the link and uploads that file to the portal, which administrator is supposed to be reviewing. The admin then goes to logins to his portal and reviews the file, tries to review that file which contains this redirect script, gets automatically redirected to the exploit hosting web server. If the browser is obviously vulnerable, he will get unknowingly exploited and will give out a interpreter session to the attacker. Now, this is not only a scenario. You can know basically if you get a interpreter session what all things you can do. This was not only a scenario. We have done this with a real world application with one of our clients. It was an internal application penetration test in which we were given access to both the normal user account as well as an administrator account. It is one of the it is very big giant application for tender management used by many giant companies. It is basically an application which allows you to a normal user can upload tenders and administrator is supposed to be reviewing that file. In that particular penetration test, we were able to actually execute this attack. Here we have just some screenshot which will show you how we have done that stuff. I hope it is visible. See, the first screenshot, it will show you that it is a Metasploit, in which we have configured Metasploit to host the exploit. In the very last line, you can see that internal URL is created, which is for the exploit. If anybody visits that URL using Internet Explorer 6, 7 or any vulnerable Internet Explorer version, using any vulnerable Internet Explorer version, the browser will get exploited and will give a interpreter session to the attacker. Here you can see that we have used a JPG image basically because the uploading function was allowing uploading any kind of data. This particular where the mouse pointer is, you can see that there we have used a redirect script which will, when a browser will execute this particular file, will redirect a user to that particular link which hosts the Internet Explorer exploit. In the next screenshot, you can see that.
Can you go back? I mean, what exactly you're doing over there?
Just zoom in a little bit. That's all.
The location not replaced.
Yeah, simple script location not replace, and we are just redirecting that user to our malicious server where we are hosting that.
It's a very simple, very basic script. It will take whoever views this file to that particular link. So this is how we have executed this attack on a live application, and this is how we are doing lots of application penetration testing and impressing our clients. So this is, you can see we have got interpreter session now. You can do any kind of stuff you want, post exploitation, sniffing the keystrokes or taking screenshots and anything, any kind of stuff. So, this is the presentation. Okay. So basically that was it. That was the main part. The next slide contains mainly the dependencies that precaution that a user and a developer can take while both visiting untrusted site or even trusted sites, visiting contains uploaded by some other users, and a developer, what a developer or a web server administrator should consider while doing their job. Configure your upload functions properly so that contains are properly validated before you allow uploading them to your web server. And obviously, web server should be configured properly so that they will be sending proper content types to browsers, not applications slash octet string or any other invalid, considering those as functionality. I'm not sure what is happening with PowerPoint now. It is not responding.
I have a question.
Yes.
You need to verify the content. I mean, you mean to say actual image you need to verify converting it to a TXT or something like that? Or?
Yeah, basically we already suggested the same solution to giant like Gmail, and they did the same thing. What they are doing right now, as they explained us, they are just getting a file. Okay, they are reading all the content, and they are just removing all the known script like HTML tags and all those tags, as they are similar. They are doing with text files as well most of the time. So this is how they mitigated this particular vulnerability. They are now just filtering all the contents of the file, remove those tags, and then upload those images. The other thing what a vendor can do is they can host these particular files on some other domain. Okay, they should not host the file on the same domain on which the application is running. So using that, they can just restrict the cookies delay and stuff. But still, as we shown that through XSS, attacker can get a Metasploiter shell as well. So that is no use. The best part is you just remove those tags from the image file. And one more thing vendor can do is, if it's an image upload functionality, they can rename all the files with JPG extension itself. So they should not be providing. Okay, so this is what vendor can do. What user can do, they just turn off the content sniffing, which can be done from Internet Explorer options. There is a option provided.
And one more question I have. You gave the script tag, right? Anywhere if you give, does it execute?
Basically, no. You need to provide that script within a 256 bytes of the file. First 256 bytes. Okay, because the content sniffing algorithm will try to recognize which kind of file by reading first 256 bytes, and after that, if it will find a script, it will consider it as HTML. Okay, if
the first 256 byte can be including any arbitrary values, or if there's a gap between any two particular sets of values.
I didn't get you. Sorry.
As in, you find some spaces like.
Yeah, as I already mentioned that to make a valid image with your script, you can do one thing. You can remove in non-important data, such as many times image will include date, creation date, then author's name. This kind of data you can easily remove that data.
How do you identify that from?
Yeah, you can simply say for that. Let's see one more. Say you can open any file like. For an example, there is a image file, default image file provided by Windows 7, that is a flower, yellow color flower. Okay, you just open that file, you will find a lot of non-important data such as date of creation, author's name, then application which created that image, and all those stuff.
That's
So,
clear text basically.
yeah, clear text. That is clear text. So you can identify easily. That's not a big deal.
What about Firefox?
Firefox, Chrome, and Safari. They were vulnerable up to Firefox 2 and 3 was vulnerable for this particular vulnerability. Safari 3.1 was vulnerable for this vulnerability. What they did is when they find application /octet string, they will not allow user to they will not check for registry to get the known application type. They will just throw a download prompt. Okay, download this application, then do whatever you want. You are not going to execute this. This kind of algorithm they have implemented, so they are currently not vulnerable as of now.
You said disabling the content filtering on the browser.
Yeah.
But it's done server side, right?
No. Basically, see, vulnerability is in browser. Okay, so there is an option in internet option that you can switch off the content sniffing algorithm. Okay, so even if the server will send you application/update thing, instead of sniffing the content, it will just prompt you a download, similar to Firefox and Chrome itself. So,
Can you show us how to say?
okay, sure. If a laptop allows it.
Delete some processes. What is it?
Yeah.
You can delete some processes.
Yeah,
What is
it's
it?
okay. We can internet option. Security. Internet custom labels.
Content filter. Above. Yeah. Up. Yeah.
No, user. Enable mind sniffing. You can disable this, then it will not sniff the contents. So this is how a user can prevent itself from this particular vulnerability. Yeah.
Anybody having so in here we already have talked about precautions, what the app owner and the user should take. So if any of you have any other questions, we can go through those. Shall we consider that? Okay, that's nice. Nobody has no questions. So at this point, I would like to thank the few. First of all, I would obviously like to thank Anil for providing us this opportunity and platform to talk. Obviously, then we would obviously like to thank our employer who allows us doing all this stuff while being there, even on site, and allows us to do any kind of stuff that we want to. Specifically, I would like to thank our manager, both mine and Anil's, Mr. Satyashil Rane, for whatever he is. He is really an awesome guy, and I just love the way he stays with us. And mainly, I would like to thank Hackers Garage. As you are all seeing, we are wearing Garage for Hackers t-shirts. Garage for Hackers is basically our online group. And it is a place for like-minded people, mostly security enthusiasts and hackers by the original definition. And basically that place is to share the knowledge that we have and learn, that's it. So these are all things.